Good afternoon, ladies and gentlemen. So as a part of the Romanian session, but actually I'm living in Romania and working for the BRIDA project. So today, we are focusing on the bridge maintenance. But first, I'd like to mention about the kind of the long span bridges in terms of the monitoring, and then the new maintenance scheme as IHI we proposed in Japan. So first, the monitoring for the long span bridges, I'd like to explain for the general information and our experience in Turkey. So as a part of the monitoring of the long span bridges, we usually use a kind of the sensors and installed on the bridges. And the system of this monitoring consists of the sensors on the bridges and the surrounding area, and connected to the data acquisition units and delivered to the control rooms and checked by the operators or monitors. And the purpose is, as shown here, the major purposes are the three purposes: the measure the real-time data and trigger the alerts for the emergency scenario, and store the historical data to be available in case of any unexpected events, and to evaluate the data to update the operation and maintenance plan for the future and for better efficiency. However, this kind of the level of monitoring depends on the bridge owner or operator or the county or authorities, and the interest on maintenance or budget or academic interest or relationship with the institute or nationality or whatever. So this kind of the arrangement should be flexible and as per the project conditions. So there is no static, fixed regulation or standards. Now, for example, in the actual situation, therefore, the girder bridges, there are too many bridges to monitor by sensors regularly, periodically. And for the long span bridges, the number are getting increased for the later bridges, but the purpose is not clear, actually. And sometimes the goals or purpose of the monitoring or installing the sensor becomes simply to record the data and the satisfied we have data. But actually, the original purpose shouldn't be like that. So, for example, looking at one specific project, we developed together with the client, the bridge owner, setting certain thresholds for each sensors, and setting some emergency scenario. For example, the earthquake, the strong wind, the ship collision, or the heavy traffic, or a high temperature situation. So as I said, the sensors has each the thresholds in for example, second or third levels, and when the value passes the values, the immediately triggering some emergency scenario and the alert to notifying to the operators, and sometimes needs to be informed to the bridge users or on the signboards. And now one example, the Osman Gazi Bridge in Turkey. So that bridge was completed in 2016. And that has the 1,550 meters of main span and passing over the Izmit Bay. So on the bridge that we installed around 400 sensors from the strain gauge to the accelerometers, inclinometers, the displacement sensors, and so on. Also the meteorological station to measure, for example, the air temperature or the wind speed. And this is just the sample photos from the bridge meteorological stations or the hangars, this vertical. No. This one, the supporting the girder, bridge girder, and the tension of this hangar is measured by the road transducer or the measuring pin at the bottom. And Apart from this bridge part, we also install some way in motion. So this measures the weight of the traffic and speed, and the axle load, weight, etc. And the recognizing also the vehicle type as well. And this is just example of the strain gauge and also the real-time data shown on the monitor. And this is interesting example of the measured data. And this is the bridge end part. And since it's about 3 kilometer long bridge, it moves like plus minus 0.5 meters due to the temperature difference. And so the above graph shows the movement of the girder end in a year. So as you see in the summertime, it's showing the negative around 0.3 meters. And in the winter time, it's about plus 0.2 or something. So it's showing the yearly fluctuation. Also in the bottom side, showing the 1 week data, and in day and night, it's showing the movement of the girder end. And not only the data from the displacement sensor itself, but also we can also compare with the air temperature measured around the bridge. So it's clearly showing the correlation between the air temperature and sonic displacement sensor. So in day and night, it moving. So with having this kind of the correlation, and we can evaluate from the structural point of view and engineering point of view the healthy condition of the bridges. Apart from the monitoring by the sensor, sometimes also we are performing kind of the site inspection by using the specific devices or mobile devices. And for this Osman Gazi Bridge, fortunately, we have a good relationship, keeping the good relationships with the bridge owner, and periodically we are visiting the site and preparing some kind of the report and confirming the good health of the structure itself. And then I'd like to show some the new scheme for the maintenance of the bridge in Japan, not in Turkey. We are also the construction company in Japan. That's why we are also interested in the bridges in Japan. And as the members from Japan already explained, there was an accident in 2012. The collapsing of the sailing in one of the tunnels. So after that, the accident, in Japan, the aviation categories of the healthy condition of the structures were developed in the 1, 2, 3, 4 categories. And especially for those 3 and 4 categories, the certain measures needs to be taken. This is the things. However, as already explained a lot, the bridges in Japan is now being aged, and the aging more than 50 years of the bridges, the percentage is now around the 35%, but in the 2040 it's getting to 75%, so drastic increase. Also, the number of the engineers in the local municipalities are getting decreased. The blue line shows the total number of the municipality, and the red shows especially for the civil engineers. So it's about 30% decreasing in the 20 years. And the left graph shows the number of the municipalities completed the countermeasures for the category 3 and 4 bridges. So it's about more than 70% of the municipalities that haven't completed yet, and or even not reaching to the half the bridges taking the countermeasures. So for this kind of situation, as already explained, there are several measures we are taking as Japan. And one of the measures are the public-private partnership, or sometimes the group management, the combining the multiple municipalities to have the how can I say, the less contracts, or to reduce the workforce, or sometimes combining the several types of the structures, not only the bridges, but also the sewage system, or tunnels, or parks. And as IHI, under the Ministry of the Land and Infrastructure, Transport and Tourism project, we developed one new bridge maintenance management method. So in the conventional method, as I explained, for the category 3, definitely repair is necessary. But as explained, the repair on the bridges under the municipalities, not the national, does not always proceed quickly, or the shortage of the engineers or budget. And not all the roads are important or having the heavy traffic. So we thought that not all category 3 bridges are required to be repaired. Then we consider a kind of the screening, and having not the categorized, not how can I say, concluding all the bridges to be repaired, but maybe we can keep periodic observation or the monitoring. And for this reason, we check the category 2 and 3 bridges. And selecting the bridge needs to be repaired or monitored, or just periodic observation is possible. And this is the detailed step of this new method. So as a step 1, we consider, for example, we make a kind of group of the bridges or the structures in the same area, or on the same route, or the same age, or similar ages. Then we evaluate based on the importance level, or like the scale of the bridges, or the external conditions, etc. And having one coefficient, developing one coefficient, and based on that, having the one first screening. And for the structures, the categorized needs to be inspected. They will do a kind of the detailed investigation on site. And sometimes, yes, the deflection test or the cracks deterioration checks. Then after those detailed inspection, we'll perform another screening, then categorize or distinguish as the bridges needs just periodic observation or monitoring or repair. And the difference between the periodic observation and monitoring is that for the monitoring, for the ones needs to be monitored, we also perform some kind of the road test as well, and having more detailed inspection. So we have just started this kind of the activities, but at the one municipality, we simulated based on their asset of the bridges and conditions. And as seen in this graph, it's obviously it's beneficial to reduce the life cycle cost about the 30% according to our calculation. And also, as explained, it's also beneficial for the effective use of the manpower and reducing the manpower on the municipality side. So it means we are combining the several bridges in one contract, so less paperwork and less manpower, something like that. Also, as a hidden advantage, it's also good for the contribution to the local economy, because we'll have one contract and having a bit the longer period. So for the local contractors, having the constant revenue or stable employment, such kind of the contribution we can also provide to the local economy. And so these are just we have started in Japan. We try to develop and expand our activity also in Japan. Thank you.
Thank you so much. Do you have any questions?